All right. My apologies for a late video upload. The last one I tried uploading um, was a share of the wrong screen. So here's here's hopefully one that works. So the main goal today was to talk about the Lightning Network and maybe two related attempts to increase the bandwidth or the throughput of Bitcoin transactions or things like it. So the Lightning Network is it's called a layer 2 protocol because it essentially changes nothing about Bitcoin transactions themselves, but it uses the Bitcoin transaction and protocols within the Bitcoin specification to manage high-speed transactions. So I guess here's the basics of the problem. Visa has about 24,000 transactions per second is the capacity. And Bitcoin, and we did this calculation a while ago, has about 7. And there's another vast difference, I guess, that is not illustrated by this. Visa, right? When you walk into a coffee shop and order a drink, you expect that transaction to take perhaps a few seconds after swiping your card, or messing with your phone in some way. Um, Whereas Bitcoin, if you recall, the standard expectation is to wait for 6 confirmations. And the first confirmation you don't get until some miner chooses to add your transaction to a block, which has to do with the size of the tip and the size in the mempool of other transactions. It might be preferable to yours in some sense. So I'll say it should take at least an hour before a Bitcoin transaction is really validated on the blockchain from the number of blocks that succeed it to validate that it hasn't been part of some kind of a fork and mistake. Um, and so that's also a pretty terrible comparison. So Visa, a total transaction with Visa is a few seconds, perhaps, whereas a total transaction in Bitcoin is usually or should be more than an hour if you are concerned about making sure that it isn't part of some fraud attempt. So Bitcoin Cash is kind of a version of this. That actually does improve things in the various ways we just talked about. So the transaction time, the blocks are larger, and the number of blocks per no the per minute, basically. So Bitcoin, there's one block every 10 minutes, or 1/10 of a block per minute. Bitcoin Cash speeds that up to one block every 2 minutes, or half of a block a minute. So if you want to wait for 6 blocks in the Bitcoin Cash world, well, that's 6 times 2 is 12. So it should take you about 12 minutes to get a 6-block confidence chain in Bitcoin Cash. And there's about 10 times as many transactions capable. But that still doesn't really compare to Bitcoin. Sorry, compare to Visa, because Visa has, it's really a few seconds for the transaction time, as opposed to, even in this situation, it's round numbers 10 minutes. Here, it's convenient, right? If you're just walking around shopping in the world, which is what people do. So scaling in the way Bitcoin moved, or the Bitcoin Cash fork happened, does alleviate some problems, but it doesn't get close to the requirements that Visa has on their network in order to support the number of transactions that's there. So what are alternatives? And so an alternative is called the Lightning Network. So the Lightning Network logically locks a certain amount of Bitcoin away in a shared wallet. So the idea is two participants in this idea of the network create what's called a multi-signature wallet, and at any point they can back out and retrieve the contents of the wallet. Their the amount of that they can retrieve has to do with contracts that the two endpoints exchange with each other. And so that's really where the idea of the lightning happens. So the contracts that are exchanged with each other aren't actually expressed in the blockchain. So the locking of the wallet is expressed in the blockchain. So that's a step that takes a little time. But the transactions that are then sent have nothing to do with, well, they are contracts which would let the two endpoints retrieve different fractions of what's stored in this wallet. And so by having those different fractions, they can essentially exchange value, right? So basically, say they both commit 1 Bitcoin into this exchange, then they can send a contract to each other and say, well, okay, I'm going to send, I don't know, a milli Bitcoin, 1,000th of a Bitcoin, right? Which is $10. Well, $15, I guess, roughly these days, from one to the other. And rather than put it in the blockchain, they just create a contract that switches how much Bitcoin they can get out of the two locked coins, so that the 10,000ths of a Bitcoin, sorry, 1,000, I just million, 1,000th of Bitcoin goes to one of the two parties. And so the balance is slightly shifting. So that's not reflected in the blockchain. It's just a contract that could be used to reflect it on the blockchain. There's enough information there to do it. And so with that amount of information, the two parties can trust that amount of money was effectively translated. So if somebody reneges on it, they end up losing all of the wallet value. So it's better to just adhere to the contract. So then the exchange continues, and basically the two sides just continue to trade contracts, where the most valuable contract is the most recent one. And so those contracts can be sent to each other as quickly as, not the Bitcoin network, but really any part of the network, just whatever way they communicate, which is probably over the internet. But that exchange is not slowed down by anything about the Bitcoin protocol. It's just sockets and network communications. So they can share these contracts quickly, and then only when they are done, they can kind of settle the score. And so the only the opening and the closing of the wallet ends up being something that you have to reflect on the blockchain, and therefore have to pay a miner their tip, right, to get that to happen. So the fees for trading the contracts are quite small. So instead of, in the order of, in US dollars, I think the round numbers are around $5 or so for blockchain transactions, recording things on the blockchain right now for miners. The fees here are in the, I believe the micro, like micro Bitcoin, like they're not even entire Satoshi, which is the smallest unit. It's something like 10 to the minus 12 Bitcoin on the order of, or maybe 1,000 times more than that, but it's still far, far less than a penny to do the exchanges. And so the cost is so low that it's essentially zero for doing the exchanges. And the rates are essentially infinite because you can use any part of the internet to send the contracts around. And then, so that's a Lightning exchange between two parties. The next layer up on the whole thing is then to have a network of such parties that have locked up value in the blockchain, and then you can exchange values by basically hopping across the wallets with sets of contracts. And again, those contracts are all just sent to the respective parties, and the respective parties don't have to put any of them on the blockchain, but they all just adjust the balance of what's in their respective shared wallets. And so the transaction time is only limited by your ability to send relatively small documents to each other on the internet. And so the network bandwidth is roughly infinite. And the lag is the lag of the internet, which is in hundreds of milliseconds or something like that. It's definitely as fast as other kinds of transactions. And the transaction fee, if you leave these multi-sig locked wallets like this out there, the cost is essentially zero if you keep them open for a long time. And the point of view would be that pairs of users can create these shared wallets, and then other users can transact through them in order to sort of reach through the network to other payers. So as the wallets are locked with each other, then the payers can exchange value across multiple links in the Lightning Network. This is the idea of the network, so that you can reach any other endpoint, and nobody has to really do anything on the blockchain. So this also increases your anonymity. So the endpoints that are using other people's wallets as a surrogate don't actually have to record anything about where the balances go to. But again, so it's a pseudo anonymity in, I guess, similar fashion to just Bitcoin, because you could like trace total amounts through such a set of exchanges and might determine like who were the real endpoints of a certain set of transactions. So you could do sort of the Tor network of breaking transactions up and then collecting them on the other side in some way. But as far as I know, that is not part of the network protocol that happens. This is part of the layer 2 part of the framework. So it solves potentially some significant problems with thinking about Bitcoin if you wanted Bitcoin to be, a global substitute for currency. If it were popular, well implemented, and broadly accepted, then it should be true that payments using Bitcoin could be settled inside of a ping time across the network, a few hundred milliseconds, something like that, and they could be done in like vast parallel quantities. So there's no one wallet that has to be used to settle the transactions. You could kind of load balance across multiple wallets as far as recording transactions, and then and the fees are quite small. So the typical fees, if you use something like Square, there's a percentage plus a base fee for each financial transaction. In rough numbers, it's usually something like 1 or 2% plus 20 cents or something like that for the fee for any transaction that happens via like Visa, MasterCard, kind of that space of transactions. And in the Lightning Network world, the idea is that those transaction fees are essentially zero. There's almost no additional cost to doing the transactions. So sort of end users tend to not really think about those transaction fees. In fact, they think about them somewhat as a bonus, because that's kind of where the cash back sort of picture shows up. The 1% that the banks offer, things like that, that comes from them cutting back and rewarding you with part of the fee, which they collect from the merchant side of things. So essentially, it's a merchant tax that the sort of end consumer doesn't see very often. It does raise prices, but it tends to be a significant margin cost for retailers. So retailers often see this as one of the more expensive like margin expenses, and they would love to have the fees be smaller. So that allows fees to be close to zero on their side. and that could be advantage. And I guess one place where it's particularly interesting is where either the charges are frequent um, and small. So sort of parking meter, phone usage sort of situations where you might be trying to bill someone maybe per minute and a very small amount, trying to record a bunch of transactions like that via the Visa mechanism or something like that is just terribly inefficient from the point of view of cost. And so that world is called micropayments, and systems like the Lightning Network are kind of solutions that are looking to sort of solve this micropayment sort of world, where people maybe can pay a small fee for. Imagine maybe using that idea to pay fees for, say, using things like Facebook. Um, in exchange for avoiding maybe their social data collection and targeted advertising. Like that might be a trade that some people would be happy to do, as opposed to kind of the social engineering aspects of things like social network sites. All right, so the Lightning Network, that let's go to the pros here. Who developed, where, and when. Pros. So it's not a very first pro. Only making its very first steps. It's actually not well enough adopted to be considered a solution right now. But as an optimist, thinking that this might work, the transaction speed. So transactions are almost instantaneous. You don't need to wait for confirmations. Once you have a contract that you can verify, which takes very little time, you're done. You don't need to wait for any block confirmations. Transaction fees. So tiny fees for using the network, and they're fractions of pennies right now for the fees right now. So imagining sort of micropayments and things like that in those worlds seem completely reasonable. Scalability, so the number of transactions is essentially infinite. It has to do with just how fast can you compute to create the contracts, and then how fast is your network connection to the internet. And so the total bandwidth has to do with everyone's connections, and in that sense it's very large. So this is not in practice yet, but what are called cross-chain atomic swaps is pretty remarkable. But the idea there is it could be possible to create exchanges where you don't have to go to trusted third party to trade cryptocurrencies between even things on different blockchains. So the cross-chain atomic swaps, the Lightning Network actually facilitates the possibility of, say, trading, say, Bitcoin, an altcoin that they were using as an example is Litecoin. And so using Bitcoin and trading it for Litecoin normally happens through trusted third party like Coinbase. But the Lightning Network actually allows those things to happen without a centralized authority. And so that's kind of remarkable that maybe that could happen, and that you could start to switch between cryptocurrencies using exchanges like this that really don't have a trusted third party, and that can be a significant advantage. The idea that nobody needs to hold the two values as a third party. So downsides, the real core one is the not fully operational. So the idea that there could be great is nice, but there really isn't the volume of pairs that are participating in the network in significant enough quantities to really make what's called a connected graph. So mathematically is like, how hard is it to get from A to B through a set of channels? And the truth is there's not really enough channels out there to support a widespread use of the network. So complexity of channels. So figuring out which wallets you need to make transactions with is fairly complicated. And of course, something that you need, software to manage that with. Channel caps. So you can't exchange more than what people have locked away in their wallets. And so that does create, I guess, it's a resource cost in the sense that what it requires is someone with Bitcoin and having them willing to lock it away in order to create these channels. And so if they're not willing to lock them away, then they can't guarantee the safety of the channel. And so therefore the channel can't carry exchanges beyond a certain limit. Like once one person exceeds the value of the wallet, then essentially they have to reclose. They have to reclose and reuse the channel. So I guess the analogy is essentially it's like putting a $20 or something like that in a bank, and then you're allowed to use a debit card. But then as soon as you hit your limit, you got to go put more money in the bank. So you can set it aside to start with. That is, the people that are creating these single pair endpoints in the Lightning Network, they lock away a certain amount of Bitcoin on the chain, on the blockchain, and then the Lightning Network can take advantage of that commitment for as long as the two endpoints are happy to leave that as an open connection, and for as long as the net balance, as money is transferred between those two endpoints, the net balance of that doesn't exceed the commitment amount on either side. So if they've exceeded the commitment amount, then it's no longer a safe channel, and it's not valid at that point. So, and then just the idea of centralization. So the number of players out there that are able to tie those together is somewhat limited. It might sort of show up as a kind of the mining pool of who really has, these days a Bitcoin is quite valuable. So how many Bitcoins would you be willing to lock up in order to support a channel that maybe other people can use, but maybe you don't care about that much? And so why would you commit to locking up Bitcoin in order to facilitate transactions that aren't really yours? And so, like, should you use it? No, it's just not put together well enough to be a thing yet. If you're interested in faster transactions and lower fees, then there are other coins out there that kind of facilitate that. So here, this is just illustration. So Bitcoin Cash, right, has much faster transactions and much lower fees also, actually. So if you're interested in just lower fees and somewhat faster transactions, there's altcoins that solve this problem in a way that are maybe more viable alternatives. We'll say, and this is not specifically about the Lightning Network, but Bitcoin Cash just this weekend went through what's called a fork, went through a hard fork with two different kinds of coins that came out of it. So their model actually is not that stable at the moment. You'll have to wait probably half a week or so. I think the outcome's pretty clear to see which parts of which ends of the fork are really the most viable endpoints. But once that's true, then Bitcoin Cash, I believe, will restabilize, and you could use them instead for a much faster trade in value, other than you have to find people that accept Bitcoin Cash. But there's other ones. So the one that I think is maybe more technically interesting is Ethereum. So Ethereum is also going through a protocol fork. There's a proposal for Ethereum 2.0. And look at that sidechain. So there really is going to be changes to the core between 1.0 1.0 basically and 2.0 in Ethereum, there's a few important adjustments. One that's not related to speeds of transactions, but they are trying to move towards a proof of stake as opposed to a proof of work implementation. And so that is a protocol change that they're trying to get to so that miners are not spending as much resources, like electricity sort of resources to participate in the network. So proof of stake is a core conceptual change in Ethereum, and then the other core conceptual change is this sidechain idea. So rather than having all of the records in one ledger, the ledger is going to be split into shards, and there'll be a core chain that really keeps track of the Merkle roots. Remember the Merkle tree kind of idea? So the roots of the corresponding trees will be recorded in the main chain, and then side chains will keep track of records. And so you don't have to keep track of all of the records, just the ones that are part of your shard. And they're all, their integrity is managed through this main chain computation work. And so it also promises to solve kind of the scalability problem, because there'll just be as many side chains as useful. And so in that way, this could significantly lower the transaction costs of Ethereum because of, well, a couple of things. One is moving away from the proof of work down to proof of stake means that miners don't have to spend a lot of computational effort. They have to make commitments about locking away Ethereum for certain amounts of time. And so that that change might lower the cost of transactions in Ethereum, but the side chains leaves room for far more capacity for numbers of transactions. So it's a different version of trying to solve this problem. So I'll just say that there's been innovation in the idea of how to get to scalability in blockchain. And certainly it doesn't seem clear that any one of these is actually one for how things will work in the near future for vast numbers of transactions. And none of them certainly are widely adopted ways of exchanging value at quickly and at low cost. So I'll say this is still a kind of an ongoing feature goal of cryptocurrencies. There's a couple of competing approaches to the idea, and the Lightning Network is, again, what's called a layer 2 protocol. It is extra protocols, just like the random number generator kind of idea, that doesn't change anything about what the Bitcoin core does, but maybe, well, could solve some significant problems if it were widely adopted. Okay, that's what I wanted to say about the Lightning Network, and I hope all of you have a good night.